Hello everyone. Welcome to Tech Info. In this video we will talk about what will happen to all the dead batteries. Millions of electric cars are coming. What happens to all the dead batteries? Thousands of cylindrical cells with components sourced from around the world transform lithium and electrons into enough energy to propel the car hundreds of kilometers, again and again, without tailpipe emissions. But when the battery comes to the end of its life, its green benefits fade. If it ends up in a landfill, its cells can release problematic toxins, including heavy metals. And recycling the battery can be a hazardous business, warns by materials scientist Dana Thompson of the University of Leicester. Cut too deep into a Tesla cell, or in the wrong place, and it can short-circuit, combust, and release toxic fumes. That's just one of the many problems confronting researchers, including Thompson, who are trying to tackle an emerging problem: how to recycle the millions of electric vehicle batteries that manufacturers expect to produce over the next few decades. Current EV batteries are really not designed to be recycled. That wasn't much of a problem when EVs were rare. But now the technology is taking off. Several car makers have said they plan to phase out combustion engines within a few decades, and industry analysts predict at least 145 million EVs will be on the road by 2030, up from just 11 million last year. People are starting to realize this is an issue. Governments are inching toward requiring some level of recycling. Complying won't be easy. Batteries differ widely in chemistry and construction, which makes it difficult to create efficient recycling systems. And the cells are often held together with tough glues that make them difficult to take apart. Before seeing to solution of this problem, we will see about construction of EV batteries. EV batteries are constructed a bit like nested dolls. Typically, a main pack holds several modules, each of which is constructed from numerous smaller cells. Inside each cell, lithium atoms move through an electrolyte between a graphite anode and a cathode sheet composed of a metal oxide. Batteries are usually defined by the metals in the cathode. There are three main types: nickel cobalt aluminum, iron phosphate, and nickel manganese cobalt. Better recycling methods would not only prevent pollution, researchers note, but also help governments boost their economic and national security by increasing supplies of key battery metals that are controlled by one or a few nations. On the one side, disposing of EV batteries is a waste management problem. And on the other side, it's an opportunity for producing a sustainable secondary stream of critical materials, says Gavin Harper, a University of Birmingham researcher who studies EV policy issues. EV battery pack. Inside the pack, electrical components manage the charge and stability of dozens of modules. To extract those needles, recyclers rely on two techniques, known as pyrometallurgy and hydrometallurgy. The more common is pyrometallurgy, in which recyclers first mechanically shred the cell and then burn it, leaving a charred mass of plastic, metals, and glues. At that point, they can use several methods to extract the metals, including further burning. Pyromet is essentially treating the battery as if it were an ore, straight from a mine, Gaines says. Hydrometallurgy, in contrast, involves dunking battery materials in pools of acid, producing a metal-laden soup. Sometimes the two methods are combined. Advantages and disadvantages of recycling methods. Each has advantages and downsides. Pyrometallurgy, for example, doesn't require the recycler to know the battery's design or composition, or even whether it is completely discharged, in order to move ahead safely. But it is energy intensive. Hydrometallurgy can extract materials not easily obtained through burning, but it can involve chemicals that pose health risks. And recovering the desired elements from the chemical soup can be difficult, although researchers are experimenting with compounds that promise to dissolve certain battery metals but leave others in a solid form, making them easier to recover. For example, Thompson has identified one candidate, a mixture of acids and bases called a deep eutectic solvent, that dissolves everything but nickel. Both processes produce extensive waste and emit greenhouse gases, studies have found. and the business model can be shaky. Most operations depend on selling recovered cobalt to stay in business, but battery makers are trying to shift away from that relatively expensive metal. If that happens, recyclers could be left trying to sell piles of dirt, says materials scientist Rebecca C. of Purdue University. To ease the recycling process, Thompson and other researchers are urging EV and battery makers to start designing their products with recycling in mind. As an example, he points to the Blade battery, a lithium ferrophosphate battery released last year by BYD, a Chinese EV maker. Its pack does away with the module component, instead storing flat cells directly inside. The cells can be removed easily by hand, without fighting with wires and glues. Recycling researchers, meanwhile, say effective battery recycling will require more than just technological advances. The high cost of transporting combustible items long distances or across borders can discourage recycling. As a result, placing recycling centers in the right places could have a massive impact, Harper says. But there's going to be a real challenge in systems integration and bringing all these different bits of research together. There's little time to waste, Abbott says. What you don't want is 10 years worth of production of a cell that is absolutely impossible to pull apart, he says. It's not happening yet, but people are shouting and worried it will happen. Thank you for watching this video.